Hello GIS 300 and welcome to week number 4. This week we are looking at census data by town from the 2010 census. You are going to be exploring some aspect of this data. For example, I have the total population per town and the percentage of each town's population that is over the age of 62. That suggests certain trends that you could discuss in a report. You may focus on the whole state, or you could look at one particular town and its surrounding area. The first part of this video is going to be all the fun that I had to get this data set where you see it now. You don't have to do the stuff with a spreadsheet. What you do have to do is a tabular join to take the spreadsheet and attach it to the shapefile. I'll show you how to do that and also demonstrate some different ways of displaying or symbolizing this data set. The tabular or table join is one of the most useful things in GIS. You might take a GIS point called point number 1, and on your field data sheets you might have a row for point number 1 and then record all kinds of data associated with it. Later on you can type up that data sheet, put it into Excel, and then merge the two together. Give spatial location to all of those attributes. So in this case we have towns. Those towns have locations here. That's the shapefile. In the attribute table the towns have names, so we have name and location for that layer. And then in the census we have a whole table of data by town. And once those two things are joined together, we have towns, we have locations, and then we have all of the census data, and these codes will make sense shortly. Here's one of the preparatory steps to the construction of this data set. So from the US Census Bureau we have Eastontown, Aroostook County, Maine. I had to separate out everything after that comma. That's this column here, so now we just have Eastontown. I had to remove counties and census designated places, which are bigger and smaller than the towns themselves. So what we're left with is the Edinburgh town and all of the data that go with it. Now I want all those data attached to the shapefile, the attribute table. I need to have all of these. Here's a shapefile attribute table. This is this column. That column has got to match because that's sort of like the zipper. It's the tabular join. It's looking for the town called Easton in the shapefile and the line called Easton in the spreadsheet. So we have a whole bunch of unpopulated townships, or townships with very low populations, but a lot of them completely unpopulated. The T10 R9, nobody lives there. There might be a camp, but it's not in the census. So I have to go through every one of these, make sure Elliotsville Township, Ellsworth City. So Elliott Town matches Elliott. Ellsworth City, now we're off by a row. I have to right click, delete, OK. And sometimes GIS is just like that. I can't find a better source of this data that's already got this town attribute. This is the most recent census data we can get with this level of detail. So it's worth coming through here, and I'm here, and I'm going to go all the way down there. So I've gotten to E, and we're going all the way down to Y or Z or wherever we have the last name. So that's the data prep step. It happens. It's boring, but that's one thing I didn't feel like I had to make you all do because it would make you all tear your hair out. I might as well just do that once and then give you the finished product. So that's the background. Now here's a frustrating thing. So I've gotten down to the M's in all this, and it's all been deleting here, and this moves up, and that's fine. But I've already removed the counties and the census designated places, but now come to find out we have the whole state of Maine represented here. So just in case you need to know, it makes sense when you're using certain kinds of software, but not this kind of software. So now I have to copy all that, paste it all down there, right click, delete the state of Maine. If your existence just blinked out, I'm very sorry. I'll snap and bring it back momentarily, but your town still exists, so there you go. And now I'm back to Manchester Town, Manchester, Mapleton Town, Mapleton, Mariaville, Mariaville, Mars Hill, Marion Township. Marion Township either doesn't have people or the people aren't in the census. So in some cases it's just not in the data. In other cases there aren't actually full-time residents. And we can definitely discuss what all that means because it means different things. But again, Marshfield Town, Marshfield, Masardis, Masardis, Matinicus, all the way down there. So Massachusetts, Gore, Mason Township, those don't exist in this other data set, so they need to go away. So now Matinicus, Mattawamkeag, Madawaskalis is not in the data set, so delete. Okay, Mattawamkeag, Maxfield, Mechanic Falls, Mayfield Township goes away. So when you have your map produced, it's going to include blanks, and those blanks are just no data. And that has to be clearly specified and just say we don't have data for this location. But for those locations we do have data, we have really an awful lot of it. Here's a nice one with Oxbow Plantation and Oxbow Township. We have Oxbow Plantation here, but we have to make sure that Oxbow Township is over here. Oxbow Plantation is over here. Sorry, this is different software than you're used to. This is ArcMap. I'm using this because I built the whole map in that software and I happen to have the towns on it, so I'm using that to check the data quality. So now I know that Oxbow Township is the one that I don't want. That can go away. Oxbow Plantation, Oxford Town, Oxford, Palermo. Here's another fun one for you. So we have St. Agatha or Citigat, and all the way down here we have St. Agatha. So I've got to do a little bit of rearranging here to make the saints match up with the saints, and that's going to be a fun time. So what I've done is selected all that, cut it. So now I'm going to go down here, next column over, paste that in. Now I'm going to move all these saints in here, cut that again, and then St. Albans, St. Francis, that needs to go away. Delete, move up a row, St. Francis, St. George, St. John. Oh, isn't that nice? St. John Plantation or St. John Township. We want the plantation, not the township, so delete that, and that goes away. Now we're all the way back up here, looking for Sandy River Plantation, and we start that here. All of those not in the data set, so now I can move here, and let's see, we want to go down, let's just go down as far as Springfield. So where's Springfield? But if I just paste that here, that will overwrite some of that, so I'm going to have to go here. And then Sandy River, Sanford, Sapling Township isn't there, so I'm going to have to delete that, shift the cells up. Scarborough Town, Scopan Town is not there, so Searsmont is our next one that exists. Searsport, Sebago, Sebaxboas, Sabumek isn't there, so delete that. Aren't you glad you're doing this? Give you a little sample if you want to try it out, but it is not a ton of fun, I'll tell you what. Delete, Shapley, Sherman, Shawtown's not there, delete Shawtown, Shirley, you must be joking, Sydney, Skowhegan, Silver Ridge and Skinner aren't there. So now Smyrna's there, Solon's, those soldier towns aren't there, Somerville, Silver Mountain's not there, we're getting close now, South Berwick, South Bristol, South Portland, South Thomaston, South Port, Southwest Harbor, Spencer Bay, that's up on Moosehead, that's not populated, Springfield there. Now, we can take all that, cut it, paste it in there. Isn't this fun? And of course all of these unorganized townships have got away. Got to go away. Words. We could do that. Okay, almost there. There we go. Alright, delete those. Nobody lives there. Getting closer now. So now, Talmadge. Academy grants. Talmadge. Delete. Yes. Good. And with Wyman Township, we finally have a perfect match all the way up and down the data with 493, less these three, so 400 towns, or 490 towns. Save that. Now we have one more problem we have to deal with before we can bring this in through a tabular join, and that is that there needs to be just one header at the top of each column. And right now we have all this extra stuff. So what I'm actually going to do is right-click here and insert a new row here. So I'm going to call this town total pop. And now I could go through and try to summarize each one of these, but the issue is that you can't have spaces in the column headers, and you can't have very long column headers. So what I'm actually going to do is call this P1, P2, P3. I'm going to select those, and I'm going to drag that all the way across. And it would just be too much to try to find logical summaries of all of these that could actually give you what you need in terms of an accurate and comprehensive summary that says everything about that. So what I can do from there is I can take all of that, copy it, Control-C, make a new workbook, right-click and transpose right here. So now, okay, let's see if that worked. So yeah, all the way down to the bottom. So I can open up that. See, I'm just double-clicking right there. That opens up so all the text that you have here, sex and age, race, race alone, so on and so forth. And then we have what the actual label is, and then what our new code is. So we have total pop. That one got a name, I guess. But P1, so if I query P1, that means how many people age 5 or under. So now you're just going to have to refer to this table and say, all right, P106 is Black or African American alone. P136, female householder, no husband present with own children under 18 years. And that, going back here, that refers to one of these columns. What does it say? 100 and, let's see, P136. P136 is here. So that's how many. There are 16 female householders, no husband present, with own children under age 18 in Abbottown. So now I can just go ahead and delete all that because I still have it over here for reference. But here I have column headers, and the reason I didn't just start with a number is it doesn't like to start with a number. It needs to start with a letter. So now I have total population in the town of Abbott, and then P1, I just have to refer to the table over here. P1 is total population under 5 years. So there are 24 individuals under 5 years in 2010. So all of these are 10 years ago, or I suppose 11 years ago now. So with that saved, I can go in through my browser here into my C drive, all the way through these folders until I get to the town level census data. And I need to open that up here so I can see these two sheets. And remember, this is the one we're actually working on. This is the one that's just sort of our reference to see which p-value means what. So I'm going to double click and bring that in. So now that exists there. Now to make the next step work, I've changed this to full name of the town. And all the way over here on the right, I've got town, which is the actual matching field here. So this is exactly the same list that the attribute table has. Now to join these two things together, we use a tabular or table join. Right-click on our towns layer, so main township 24 to shorelines, properties. Once that opens up, go to joins here, and you'll see this blank white page, and that's where you want to be. Now we're going to hit this green plus and add our join. So that's 2010 demographic profile. That's by default. If you don't see it, you can select it from the drop-down menu there. Join field, we have to scroll all the way down to town. And the target field is also town. So town matches to town. Leave the rest and hit OK. And there it is. I'm going to hit apply and then move over to Symbology here. First, I'm actually going to turn these labels off. I don't want those labels anymore. No labels. Apply. Good. Now Symbology. Single symbol. Change single symbol to graduated. value. Now we have all of these options. So which one do we want? Referring to our table here, I would like to know, population 62 years and older. And remember, this was 2010, so these will now be 72 years or older. So let's look and see 62 years and older, that is P23. So I want to display by P23. Move those out of the way, go here. The value we want is P23. Thank you very much. We'll go from white to dark red, hit apply, and let's see what we get. We get nothing. We have to classify first, so hit the classify button, and there it is. Now apply. And that tells us something very simple. That is how many people in each town are over the age of 62. Now my computer just crashed, or at least crashed the software. The computer's fine. So I'm going to do something that's going to sort of take the load off its little brain here, because right now it's trying to hold that join in its memory, and that's not the best. So I'm going to right click, export, save feature as, and I'm going to call this I need to save it somewhere first, so I'm going to save that here and call that me towns census.shp, and that's what I'll work on from now on. So add save file to map. Oh, why are we sad? Too many field names. Truncated, Oh, come now. So I'm keeping this in here because it's good for you to see how this works. So 2010 demographic profile, that comes from here, which in turn came from here. So this is too long, because when this gets added on to that, the whole thing is too long. It tries to chop off to here, and then all of these are the same. So I need to rename that. I'm just going to call that C for census, because then it'll be C underscore P155 when that's all said and done. So save, and then I'm going to redo that join. You'll do this way the first time. So now this sheet here, C, which was originally this 2010 demographic profile, that's what it is. Right click on our town bounds, joins. If I had to remove the join using the minus here, and now I'm going to add a new one here. From C all the way down to here, I want to take the town, join the town, okay. Now I can right click for it to listen to me, export, save feature as, give it the file name here, me towns census c.shp. And now, keeping the same UTM zone and everything else, add save file to map. Okay, thank you. So this is what I'm working with. I can uncheck that. Now I just have the great and good state of Maine there. I can right click, properties, then go to my symbology, and then graduated colors. Make that value P23. So now you see how it's all C underscore P23, and that makes sense. That's short enough there. And we can refer to our table. This is, again, individuals over the age of 62. Apply. And again, classify and apply. There we go. Okay. But is this very useful? No, it's not. It's just showing where there's a lot of people, and where there's a lot of people, there are going to be a lot of older people. That's just the way it works. So what we need to do is to represent P, or P23, or the people of age greater than 62, as a percentage of the total population. To do that, we need to go into the attribute table. So right-click, open attribute table, and we are going to click on the button here when it lets us open field calculator. We are creating a new field. The output field name is going to be %62, and the expression is going to be C underscore P23, which remember was our code for individuals over the age of 62, not 65, that's P24, and that's going to be divided by total. Where did I put that? C, it's got to be C underscore total pop. So C underscore total pop. So the number of individuals over the age of 62 divided by the number of individuals total. If we want to get super fancy about that, we can put that in parentheses because order of operations, so you knew you'd use that someday, that PEMDAS stuff, times 100. Okay. And now, all the way to the right, we have the percent over 62. Close that, and now we can go in here into properties, into the symbology, and instead of displaying by P23, we can go down and display by the percent over 62. And this time we remember to say classify, and there it is. So we have from 9 to 17 and all the way up to there. And now we have a choice here. How do we display that? So right now it's in equal count or quantile. That means if we have 5 categories, it's going to put an equal number of towns into each category. So say we had 500 towns, so it would be 100 in first category, 100 in second, and 100 in each of these. Sometimes useful, sometimes not. Let's try equal interval. There it is. In this case, the size of the group is going to be the same. So 9 to 21 is 12, or 21 minus 9 is 12. 32 minus 21 is 11. 44 minus 32 is 12. And yes, I used a calculator before I started this recording. I'm not that smart. I think that's going to give us the best representation by color coding here. So apply. And OK. And now we see a very different trend. Make of that what you will. And we can do a similar thing like we did with the DEM last week, I suppose. Yes, last week. We can right-click and duplicate the layer, which again doesn't duplicate the whole data set, but it gives you another set of instructions on how to display that data set. So let's say we want to be able to flip back and forth between the proportion over the age of 62 in 2010 and the total population of the town in 2010. So we can go to properties here, symbology, value, scroll all the way back up to the top and see total population, classify, and let's give that a different color because why not? Show that in shades of blue. Okay. And see that equal interval might not have been the best way to display that data. It doesn't show the trend very well at all. Let's go ahead and try something else. Let's try quantile in that case. That might make some sense because it's, of course, not a proportion. It's a total count. Let's try it out and apply. Okay, that makes a bit more sense. Let's take a look. There we go. So we have towns greater than 3,000, 1,500 to 3,000. That makes better sense. But does it make perfect sense? No, 3 to 324, this is not the best. So let's go ahead and actually change that to something of our own choice. We can, again, change the values here. Just double click on that and we'll say lower value 3, upper value 500. Round numbers are nice. See how it changes here? Double click on that. 500 to 1,000. That makes sense. 1,000. No, don't click on the color. That changes that. Click here. Let's say 1,000 to 5,000. Okay. And then see that confused that a little bit because 5,000 to 3,588 makes no sense at all. But we're going to change that. So let's go ahead and change that to 15,000. And now 15,000 all the way up to the huge city of Portland there. Okay. And see how that all changes. The logic of that is that Fort Kent, with about 4,000 people, shouldn't show up as the same color as the city of Portland. So now, if we make sure that's checked on underneath, we can check and uncheck the top layer and make a quick comparison between those two ways of visualizing the same big data set. Of course, it's not the same data. One is showing the total population of each town, and the other is showing to be proportion, or the percentage of that town, that was over the age of 62 in 2010. So we can see that a lot of these are smaller towns by population with a higher percentage of individuals over the age of 62. So all of that is based on the total population and the population 62 years and over. So that's P23 divided by total population. You can do the same thing with any of these. And I've realized it may be easier to interpret this looking at it in its original untransposed format here. So we have subject and total populations, so every one of these you can click on and read up here what they are. But we have every one of those, or I could be helpful here. and select all of those, double click. Now that's given you enough to read everything here. So now I can see race, 19 columns, universe, total population. So total, one race alone, white, black, American Indian, Asian total, different categories of that, and all sorts of interesting information you could pull out of here. So you could look at where people are living, what proportion they are of the total population, those kinds of questions. And then the finished product is a map or maps telling the story. You know how to do that. Project, new print layout, and we'll call that the 2010 Census 62 higher. Okay, and now we have the issue where the state of Maine is really more of a portrait orientation, the landscape orientation. To change that, just right click in anywhere in here and hit page properties, and then we can change the orientation from landscape to portrait, like so. And now we can add our map here, snap to the corners, drag to the edge, and there it is. We can change scale here. So let's try 300,000. Oh, that was 30,000. Try 300,000. There we go. Not it. 200,000. Pretty close. 175,000. No, that's 17,500. 175,000. Pretty well right on. And we can move that around as we see fit. From there, a title. So we need to add text here. Make that text box like so, and a nice descriptive title goes here. Call that Maine 2010 Census, percent individuals over 62. Enter. And now we need to make that center alignment, and I want that to be quite a bit bigger. Change that under font. One click gets us there, and let's try size 28. That needs to be dragged out to there. Individuals over 62, and it's rearranging for me, that's fine. Maine 2010 Census, percent individuals over 62. If we want to be really specific about that, we could say by town, and might as well hit enter there. By town. Okay, so that is a very descriptive title. It tells the reader exactly what they're looking at. Let's get that arranged well enough there. Let's go ahead and give it a scale bar here. 0, 25, 50 kilometers. Oh dear, I'm resizing that. Click and then move that wherever we see fit. Seems to fit nicely enough there, and let's change that to miles. And see, let's change that to 0, 10, 20. That's actually pretty alright. 20 mile scale bar is just fine. Now I'll give it a north arrow here. Where is our north arrow? Let's go ahead and put the north arrow in the, just put it right here by the scale bar. Put that there, and let's see, that was under symbols. No, it wasn't. Where was that? Wind roses? No. Oh, where did we put that? Arrows, of course, with a westerly declination. Now, zooming in on this, we have a little issue. There's a star for the North Star up here, but we can't see it because it's on a white background. If we go ahead and zoom in here, we can scroll down and change our fill color from white to black, and now we can see the star. Just make that a touch bigger. We'll put that right there, and then we'll add some text here saying magnetic declination. Minus 16 degrees west. And that needs to get out of the way. That needs to go there. That needs to be bigger, wider, and change the font. Doesn't need to be huge. Let's make that font size 7. Make that fit there. Click off there. Change this to be center justified. Makes that nicer. And make that fit, and plop that right there. And now that's that done. And now I'm deciding I want to move that a little bit higher. So I'll go ahead and give that just a touch more margin there, but I really want this north arrow to be up here in the corner, and its text has got to go with it. So there it goes. That just leaves the legend. So there's that. Click, hold, drag, release the box. So that's your legend button. And let's go ahead and only show the items inside the linked map, which is that one thing there. That can go in the bottom right. Give it a little bit more space. And now we need to double click on that. Come now. You can do it. Oh, we have to uncheck auto update first. And now we can change that. Double click. And we'll call that the percent population over 62. There we go. And as before, layout, export as image. I'm going to call it as it wants to be, 2010 census. There we go, export, think. Bring that up, census 22 higher, and there is the finished map ready to go into the Word document. If I was to tell this story, I would have the other map showing the overall population of towns and compare the two. Your assignment, very briefly, will be to find some pattern in this data set and explore it, making a map or maps to support the write-up.